Far beneath the world we walk on, past the soil, past the layers of stone, into the hidden darkness of the earth, something ancient is always moving. For centuries, humanity has built its civilizations atop a crust so seemingly solid, so reassuringly stable, that it's easy to forget how thin and fragile it truly is. Beneath that brittle shell, forces older than time itself churn and heave, shaping the very face of our planet in ways both seen and unseen. We live our daily lives upon the surface, rarely pausing to wonder what lies below. Our roads, our cities, our monuments, everything we treasure, sits atop a floating mosaic of plates, drifting slowly across a molten interior. Most days, the movements beneath us are imperceptible, the silent breathing of a planet in constant motion. But sometimes, when the instruments are sensitive enough, when the watchful eyes above are sharp enough, something strange comes into focus, something that defies simple explanation. In recent months, an unusual set of observations has captured the attention of scientists at NASA. High above the Earth, sophisticated satellites, designed to measure even the slightest changes in the planet's surface, have detected peculiar disturbances, subtle, wave-like motions traveling beneath the crust. These ripples are not like the violent tremors of an earthquake or the furious upheaval of volcanic activity. They are something different, quieter, more elusive, and far more intriguing. It began as a faint signal, almost lost among the background noise of Earth's endless tectonic hum. But as the days turned into weeks, the anomalies grew harder to ignore. Patterns began to emerge. Patterns that did not match the expected movements of tectonic plates or known seismic events. It was as if the Earth itself was murmuring a message, too faint for ordinary senses to detect, but unmistakable to the advanced eyes and ears orbiting high above. NASA's vast network of observational satellites, machines built to study weather, climate, sea levels, and even the smallest shifts in land masses, soon began reporting unusual data from multiple regions. Regions where the ground, by all previous accounts, should have been still. These ripples were not confined to the familiar danger zones along major fault lines. They were appearing in areas traditionally considered geologically quiet, places where earthquakes were rare and volcanic activity virtually non-existent. At first, the disturbances were subtle. Tiny deviations in satellite radar, minor anomalies in gravitational readings. But the more data scientists gathered, the more perplexing the picture became. This was no isolated event. It wasn't the aftermath of a single seismic outburst. It was a continuing phenomenon, one that seemed to pulse across vast distances, below mountains, deserts, plains, and oceans alike. Something was stirring beneath the world we know, moving through the deep earth in ways we had not seen before. And it wasn't just one set of instruments reporting this. Across a range of independent systems, LiDAR mapping, infrared imaging, ground-based seismometers, similar anomalies were being recorded. Tiny, rhythmic pulses. Gentle, persistent motions. Patterns that hinted at a force operating on a massive scale, yet somehow escaping the dramatic violence usually associated with geological change. Inside NASA's control rooms, data analysts and geophysicists leaned closer to their monitors, comparing waveforms, plotting displacement maps, recalibrating their models. What they found only deepened the mystery. The ripples were real. They were measurable. They were moving with a consistency that suggested a process at work far beneath the surface. But a process unlike anything typically seen in Earth's geological record. For the moment, the observations remained just that, ripples, measured and catalogued, waiting for explanation. No immediate threat has been announced, no emergency declared. Yet within scientific circles, there is a growing sense of urgency. A growing sense that what we are witnessing might be the early signs of something significant, something that challenges our understanding of the Earth's interior. In the grand sweep of Earth's history, change has never come without a warning. Sometimes the warning is loud and violent, a sudden quake, a volcanic explosion, a roaring tsunami. Other times, the warnings are quieter, subtler, whispered in signals so faint that only our most advanced tools can hear them. Now, before we continue, we would like to encourage you to consider subscribing. And so today, We stand at a crossroads of mystery and discovery, watching from above as the planet stirs below. The surface remains calm. Life goes on. But beneath it all, strange ripples are moving through the deep places of the Earth, leaving scientists to wonder, what, exactly, is happening beneath our feet? In the wake of these puzzling discoveries, scientists began to search for answers, carefully, methodically, and with a healthy respect for the unknown. Among the earliest and most intriguing possibilities floated by the geophysical community was the idea that these strange ripples could be tied to an ancient, slow-moving phenomenon deep within the Earth's mantle, the gradual movement of superplumes. Superplumes, sometimes called thermochemical upwellings, are vast columns of hot, buoyant rock rising from near the boundary between Earth's molten outer core and its solid mantle. These plumes are unimaginably massive, hundreds, even thousands, of kilometers across at their base, and they have the power to reshape continents, alter ocean currents, and drive volcanic activity on a global scale. Unlike the sudden violence of an earthquake, a superplume moves with a patience that borders on timelessness, shifting and churning the deep interior of our world over millions of years. In a sense, the Earth itself breathes through these plumes. They are the great hidden engines behind much of the surface change we see, the silent architects of continental drift, ocean basin formation, and even mass extinctions in the distant past. If one of these superplumes were becoming more active, if its restless motion had begun to push upward just a little more forcefully, it could easily produce the kind of subtle, widespread rippling that NASA's satellites have now detected. The idea is compelling, and not without precedent. Geological records suggest that superplume events in Earth's history have triggered profound environmental shifts. Roughly 120 million years ago, the rise of a massive plume beneath what is now the Indian Ocean led to the formation of the Deccan Traps, a colossal expanse of volcanic rock, and may have played a role in shaping global climate patterns for millions of years thereafter. Similarly, the breakup of the ancient supercontinent Pangaea, an event that dramatically rearranged Earth's geography, is believed to have been influenced by plume activity deep within the mantle. If the strange ripples now being detected are the surface's faint reaction to a stirring plume far below, it would mark the beginning of a slow but powerful transformation, one that would not unfold over days or weeks, but over centuries and millennia. Yet the signs would be there, for those careful and fortunate enough to notice. A gradual shifting of tectonic plates, a subtle warping of land masses, an increase in volcanic and seismic activity in places long thought dormant. What makes this possibility even more fascinating is the extreme difficulty of studying superplumes directly. Because they lie so deep beneath the surface, often starting near the core mantle boundary, almost 3,000 kilometers down, they cannot be observed directly by any means available to us. Instead, scientists must infer their presence by studying seismic wave patterns, by modeling heat flow through the planet's layers, and now, perhaps, by carefully interpreting the kind of surface anomalies that NASA's satellites have begun to reveal. For researchers who have spent their careers chasing the elusive movements of Earth's interior, the detection of unexplained ripples is both exhilarating and daunting. Every blip, every anomaly, every faint disturbance in the satellite readings could offer a clue, a piece of a puzzle so vast that it stretches back to the very formation of the planet. Yet the answers will not come easily. The deep Earth guards its secrets well. Adding to the intrigue is the fact that superplume activity does not necessarily announce itself with a single, dramatic event. Instead, the process can unfold almost imperceptibly at first, with slow swelling of the crust, minute changes in the tilt of land masses, or tiny shifts in gravitational fields, signals exactly like those now under scrutiny. The Earth, it seems, rarely shouts when it is about to change. More often, it whispers. And while a superplume rising beneath the crust might take thousands of years to make its full presence known, the early stages of that ascent, the ones that could be unfolding now, might look very much like what NASA's instruments are currently recording. A planet stirring in its sleep. A restless giant turning in the dark. Of course, not all scientists are convinced. Some caution that the ripples could be the result of more localized processes, or that they may even stem from errors or distortions in the satellite data itself. But for those who have spent decades studying the deep Earth, the pattern forming beneath our feet bears an eerie resemblance to the early signatures of ancient upheavals recorded in the geological archives of the past. The implications of a rising superplume are staggering. Over immense spans of time, such a force could remake continents, trigger massive volcanic eruptions, alter climate patterns, and send shockwaves, both literal and metaphorical, through every aspect of life on Earth. Yet in our own lifetimes, the effects might remain subtle, almost ghostly, the land lifting by mere millimeters each year, new volcanic fields slowly forming in unexpected places, once stable regions becoming seismically restless. In a world already grappling with rapid environmental changes, the idea of the planet itself entering a slow-motion transformation is as humbling as it is unsettling. It reminds us that despite all our technology, all our mapping, all our seeming dominion over the surface, we remain passengers on a world still very much alive, still changing in ways we can scarcely predict. And so, as NASA's data continues to pour in, as analysts labor to refine their models and search for patterns within patterns, the possibility remains that somewhere deep below us, one of Earth's ancient giants has begun to stir once again. The ripples are real. The questions are mounting. And the true cause may be a story millions of years in the making, unfolding now beneath our unsuspecting feet. But what, exactly, would the early stages of a superplume's awakening look like? To understand the delicate signature of such a phenomenon, we have to stretch our imagination deep into the hidden architecture of the planet itself, into realms where pressure is so great and temperatures so high that ordinary rock behaves more like a slow-moving liquid. In this bizarre, twilight world beneath the crust, heat from the Earth's core bleeds outward in sluggish currents, twisting and folding the solid mantle above it like an endless, simmering tide. In these crushing depths, the seeds of a superplume are sown. Over unimaginable spans of time, slightly warmer pockets of material gather, buoyed by the tiniest differences in temperature and density. These upwellings are incredibly ancient. Some may have been quietly growing since the days when dinosaurs still walked the Earth, or even earlier, when the very first continents were still taking shape. The birth of a superplume is not an event, but a process, a slow awakening of deep forces that have slumbered for eons. If a superplume is indeed beginning to assert itself now, as the ripple patterns suggest, it would represent the culmination of millions of years of slow, invisible preparation. Beneath our continents and oceans, vast tongues of warmer, slightly less dense material could be reaching upward, softening and warping the base of the lithosphere, the rigid outer shell of the Earth, just enough to create detectable disturbances on the surface. And this is where NASA's findings become even more tantalizing. The ripples detected are subtle, stretching across wide areas like a giant, low-frequency drumbeat felt more than heard. There is no single epicenter, no obvious crack or rupture in the surface to point to. Instead, the disturbance appears almost like a breath, a gentle, rhythmic pulsing that defies easy categorization. To the trained eyes of geophysicists, this is precisely the kind of whisper one might expect from a superplume flexing its muscles for the first time in ages. One of the most curious aspects of this possible plume activity is the scale. Unlike an earthquake or a volcanic eruption, which can be pinpointed to a specific location, a superplume's influence spreads out over thousands of kilometers. It's not a sharp jolt but a slow, all-encompassing heaving of the crust itself. Think of it like the gradual swelling of dough as yeast works its slow magic from within, imperceptible moment to moment, yet undeniable when viewed over longer periods. This kind of broad, diffuse motion presents a serious challenge for researchers. Traditional methods of studying geologic activity, seismographs, field observations, even GPS measurements, are often geared toward detecting sharp, sudden events. A superplume, by contrast, operates on a scale and a timeline that tests the very limits of human patience and technology. Satellites offer a unique window into this deep time process, allowing scientists to piece together tiny shifts over months and years, shifts that would be invisible from the ground. Yet even with all this technology at our fingertips, distinguishing a true superplume awakening from other forms of subterranean motion is a daunting task. The mantle is not a uniform, featureless sea of molten rock. It is filled with currents, eddies, and discontinuities. Localized mantle plumes, smaller, isolated upwellings of hot material, are common and can produce similar, though much more modest, surface effects. A true superbloom, however, is a behemoth on a different order entirely, a leviathan of geological forces whose influence reshapes entire regions. The sheer potential scale of the ripple patterns detected by NASA hints at something truly enormous lurking far below the crust. If confirmed, it would be among the most significant geological discoveries of the modern era, not just a footnote in the story of Earth's evolution, but a major new chapter. It would challenge existing models of mantle dynamics, prompt new investigations into continental stability, and raise serious questions about how Earth's surface might respond in the coming centuries. Even more intriguingly, the location of the ripples may offer subtle clues about the nature of the superplume involved. In past studies, the largest known superplumes have tended to form beneath regions of thin or fractured lithosphere, places where the rigid outer shell of the Earth is already weakened, offering less resistance to the relentless upward push of molten rock. If the current ripple patterns are concentrated in such areas, it would strengthen the case that a deep mantle upwelling is at work. Of course, a rising superplume would not make itself known in isolation. As it exerts pressure on the underside of the crust, it could set off a cascade of secondary effects. Tiny changes in local gravity fields, shifts in the behavior of ancient fault lines, subtle variations in volcanic gas emissions. Like detectives following a trail of faint, half-erased footprints, scientists must sift through 1,000 tiny anomalies, weighing and connecting each clue to build a coherent picture of what is happening. Every data point matters. A single satellite pass revealing a slight bulge in the land, a tiny but consistent shift in GPS coordinates across a wide region, an unusual pattern in seismic wave reflections, all could become pieces of the larger puzzle. This is not just science, it is a slow, careful listening to the deep murmurings of the Earth itself, a tuning of human instruments to the vast and ancient rhythms that pulse far below our feet. It is humbling, too, to realize how little control we have over these forces. We may drill into the crust, we may map the oceans and chart the stars, but the true heart of our planet remains largely beyond our reach. If a superplume is indeed stirring, there is little we can do to influence its course. At best, we can strive to understand, to read the signs as they unfold and prepare for the long, slow changes that may lie ahead. As scientists continue to pore over the data, refining their models and seeking confirmation, the mystery deepens. For now, the ripples are a whisper, a hint, a suggestion. But if history is any guide, whispers from deep within the Earth have a way of growing louder over time. And so, with eyes turned to the skies and ears pressed metaphorically to the ground, we wait. The story unfolding beneath us is ancient, immense, and profoundly alive. Whatever is happening deep under the crust, it is a reminder that our planet is not a finished masterpiece, frozen in time. It is a work in progress, a dynamic, restless world whose deepest secrets we are only just beginning to glimpse. Yet, as compelling as the superplume theory may be, it is far from the only explanation scientists are considering. Another possibility, one that has sparked quiet but growing conversations among geologists and geophysicists, revolves around something perhaps even more unsettling: the gradual destabilization of ancient tectonic plates buried deep beneath the Earth's surface. Known as subducted slab graveyards in the scientific community, these vast, broken remnants of long-lost tectonic plates have, for millions of years, lain hidden beneath the crust, stacked atop one another like forgotten ruins at the bottom of the mantle transition zone. Once vibrant, active conveyors of continents and oceans, these slabs were forced deep into the planet during powerful subduction events, moments when one plate dove beneath another and disappeared into the crushing depths. For the most part, it has long been assumed that once these slabs vanished from the surface, they simply became inert, heavy, static layers slowly sinking and merging with the surrounding mantle. But in recent years, a wave of new research has begun to challenge that assumption. What if these ancient fragments are not entirely passive? What if, under the right conditions, they could shift, collapse, or even partially reawaken, sending shockwaves through the surrounding material and rippling all the way to the surface. It's a theory that, at first glance, seems almost too extraordinary to be real. Yet the deeper scientists look, the more plausible it becomes. To truly grasp the gravity of this idea, we must first understand the life cycle of a tectonic plate, not as a flat, featureless sheet, but as a dynamic, three-dimensional body stretching deep into the earth. When a plate subducts, it doesn't simply vanish beneath the crust like a coin slipping under a rug. Instead, it plunges downward into the mantle, dragging along a tongue of cold, rigid rock that can extend for hundreds, even thousands of kilometers. Over tens of millions of years, these slabs encounter the mantle transition zone, a strange, shifting boundary located roughly 410 to 660 kilometers beneath the surface. Here, the chemical and physical properties of the mantle change dramatically, creating a kind of bottleneck where subducted slabs tend to accumulate. In this twilight realm, ancient tectonic plates linger like phantoms, layered atop one another, slowly cooling and compacting under unimaginable pressure. But here's where things get fascinating. Recent seismic imaging techniques have revealed that these so-called graveyards are not uniform or serene. Instead, they are riddled with fractures, gaps, and irregularities, evidence that the old slabs are not simply dissolving into the mantle, but are actively deforming over time. In some cases, entire segments of a slab can break off, fold over themselves, or collapse downward like a crumbling skyscraper. If such a collapse were happening now, especially beneath a region already stressed by mantle dynamics, it could easily create the kind of broad, rhythmic ripples detected by NASA's satellite data. Imagine a colossal piece of rock, hundreds of kilometers long, suddenly shifting position deep within the Earth. The energy released would not be like an earthquake, with a sharp, explosive rupture, but more like a massive, slow-motion settling. The ground above would feel it as a subtle, persistent undulation, a breathing, almost imperceptible movement, eerily similar to the patterns being observed today. Moreover, the collapse of a subducted slab could also explain another curious aspect of the anomaly: its geographical spread. Unlike typical seismic events, which are tightly localized, a slab destabilization event could influence a vast area, subtly altering the stress fields across thousands of kilometers. Tiny shifts in pressure would propagate outward through the crust, bending and warping it in ways that traditional geological models struggle to predict. Adding another layer of intrigue is the timing. Geological records suggest that Earth experiences periodic pulses of tectonic activity, moments when ancient stresses are released in a cascade of movements, reshaping continents and oceans in relatively short periods of time. Some researchers believe we may be entering one of these pulses now, triggered by complex interactions between surface plates and the hidden graveyards below. If so, the ripples detected beneath the crust could be just the first whisper of a much larger story beginning to unfold. The location of the current ripple activity adds even more weight to this theory. Many of the regions showing anomalous movement are situated near ancient subduction zones, places where oceanic plates once disappeared into the mantle long ago. Though those events are lost to history, the scars they left behind persist deep underground, invisible but very much alive. If a segment of one of these buried plates is now shifting, it would make perfect sense that the surface above would begin to move in strange and unexpected ways. Of course, detecting and interpreting such deep events is a monumental challenge. Unlike volcanic eruptions or earthquakes, which announce themselves loudly with surface drama, the collapse of a subducted slab is a subtle, almost ghostly event. It leaves no ash clouds or fault lines, no rumbling aftershocks to pinpoint its location. Instead, scientists must rely on indirect measurements, tiny variations in seismic wave speeds, gravitational anomalies, and now, satellite-detected surface ripples, to infer what is happening miles beneath their feet. There's a poetic irony in this, that some of the most profound movements of our planet occur not with a bang, but with a sigh, a slow, ponderous adjustment of ancient bones shifting in the deep. It's a humbling reminder that Earth's history is not a series of isolated catastrophes, but an ongoing conversation between the surface and the depths, a dialogue carried out over epochs and eons. If the slab graveyard theory proves correct, it would also have profound implications for our understanding of geological time scales. Events we once thought of as instantaneous, like mountain building episodes or the opening and closing of ocean basins, might, in fact, be just the surface echoes of long-buried structures slowly coming undone beneath us. It challenges our very notion of stability, reminding us that even the most ancient parts of the Earth are never truly at rest. In the coming months and years, researchers will no doubt turn their attention toward this theory with increasing focus. New seismic imaging projects are already being planned, aiming to peer even deeper into the mantle's hidden chambers. Satellite networks will continue monitoring the subtle movements of the crust, hunting for patterns that could confirm, or refute, the idea of slab destabilization. For now, though, the buried plate theory remains an enticing possibility, a window into the deep time drama playing out beneath our seemingly solid world. The ripples detected by NASA may yet prove to be the first visible traces of a profound subterranean shift, a movement born not of surface chaos, but of ancient structures, slowly stirring after eons of silence. To truly appreciate the depth of this theory, one must also consider the remarkable complexity of the mantle transition zone itself, the strange environment where these ancient slabs reside. Far from being a simple boundary, the transition zone is a labyrinth of different minerals, pressure states, and temperature gradients, each of which plays a critical role in determining the fate of subducted plates. At around 410 kilometers deep, olivine, the most abundant mineral in the upper mantle, undergoes a dramatic transformation into a denser structure known as wadsleyite. Then, at around 660 kilometers, wadsleyite itself transforms yet again, this time into ringwoodite, another high-pressure form. These mineralogical shifts are not trivial. They change the way rocks behave, altering their viscosity, their strength, and even their ability to conduct heat. When an ancient slab enters this zone, it encounters a geological gauntlet. Portions of the slab may harden and become brittle, while others soften or partially melt, depending on local conditions. Such varied responses within a single slab can introduce tremendous internal stresses, tensions that build quietly over millions of years until, inevitably, something must give. One fascinating aspect scientists are exploring is the possibility that water trapped within these slabs plays a far more significant role than previously realized. Studies of ringwoodite samples brought up from deep within the earth suggest that the mineral can hold significant amounts of water, not in liquid form, but locked within its very structure. In fact, some researchers now believe that the transition zone may be saturated with enough water to equal several oceans' worth, hidden deep inside the mantle. If a subducted slab contains such locked-in water, the implications are profound. Under the intense heat and pressure of the mantle transition zone, the water could be released over time, dramatically altering the physical properties of the rock around it. Areas that were once rigid could become ductile and weak, creating zones of instability within the slab itself. Eventually, entire sections could buckle, fold, or collapse, setting off the slow, powerful movements that are now being detected at the surface. This slow wet weakening process would not produce sudden earthquakes or volcanic eruptions, but rather a gradual, almost imperceptible settling, a silent reconfiguration of deep earth structures. The strange ripples NASA observed could be the surface's quiet response to this deep, almost secretive drama playing out hundreds of kilometers below. In fact, one of the most compelling aspects of the slab destabilization theory is just how silent the entire process might be. Unlike familiar geological events that announce themselves with ground shaking and roaring explosions, a collapsing subducted slab would release its energy in whispers. The ripples would be broad, slow-moving, and sustained over long periods of time, perfectly matching the anomalies picked up by sensitive satellite measurements, but easily missed by traditional seismology. Furthermore, when examining the geographical distribution of the observed ripples, it becomes increasingly clear that many are located near known ancient subduction zones, regions where oceanic plates were swallowed up in the distant past. This pattern would be difficult to explain through surface-based processes alone, but it fits naturally with the idea that the remnants of these plates, deep beneath our feet, are beginning to stir once again. Even more intriguingly, some researchers speculate that the current destabilization might not be limited to a single slab or region. Given the interconnected nature of subduction systems over Earth's history, it is entirely plausible that several ancient slabs are destabilizing at once, influenced by subtle shifts in global mantle dynamics. A cascade of such collapses, though incredibly slow by human standards, could create a wave of surface changes observable over large areas and extended timeframes. Adding to the complexity is the role of temperature anomalies within the mantle. Not all parts of the transition zone are equally warm or cold. Thermal plumes rising from the lower mantle, or cooler regions left over from ancient subduction events, can create pockets of varying stability. A slab fragment trapped in a slightly warmer region might soften and sag sooner than one embedded in a cooler, more rigid zone. Such thermal contrasts could create a patchwork of moving and static zones within the deep Earth, with stress focusing along their boundaries. In these critical zones, stress could accumulate slowly and inexorably, until a tipping point is reached. Then, the collapse or downward flow of an ancient slab section could begin, not violently, but with immense, relentless force. And as it moves, it would drag and distort the surrounding mantle material, sending broad, deep-seated waves of deformation outward and upward, eventually reaching the brittle crust above. This entire process paints a portrait of a restless Earth, not one driven solely by surface forces like plate tectonics and erosion, but animated from within by slow, ancient battles between density, pressure, and temperature, a hidden world of change, unfolding at a pace almost too slow for the human mind to comprehend. If this theory proves correct, it would reshape how we think about the stability of continents and ocean basins. What appears to be static on the surface, the unmoving bedrock beneath our cities and mountains, may, in fact, be floating atop deep, unseen seas of slow, creeping movement. It would suggest that Earth's surface stability is not a given, but a fragile balancing act, maintained by processes happening hundreds of kilometers below our feet. To capture these faint signals and decipher their meaning requires extraordinary scientific ingenuity. Researchers are already pushing the limits of seismic tomography, gravitational mapping, and deep Earth modeling in an attempt to see what cannot be directly observed. Each new data point adds a pixel to the fuzzy image of the deep Earth, a picture that, little by little, is beginning to reveal the profound dynamism hidden within our seemingly solid world. As NASA's satellites continue their tireless watch from orbit, and as Earth's own subtle movements are measured with ever-increasing precision, we may, in time, confirm that the ancient dead, those long-forgotten tectonic plates, are not so dead after all. They are still shifting, still speaking, still shaping the world we live in ways we are only now beginning to understand. While the destabilization of ancient slab graveyards offers a compelling and grounded explanation, a growing body of more speculative thinkers has begun to explore an even stranger possibility, one that stretches the limits of our current understanding of Earth's interior. Some scientists and futurists propose that the strange ripples detected under the Earth's crust may not be the result of familiar geological processes at all, but rather the manifestation of a deep, hidden energy source awakening far beneath our feet. This theory suggests that somewhere in the deep mantle, or even closer to the core mantle boundary, a vast, natural energy reservoir may be undergoing an unstable phase. An ancient geothermal reactor, so to speak, operating on principles not unlike a massive nuclear battery, could be responsible for sending slow, powerful pulses through the Earth's structure. While it may sound like the stuff of science fiction, the idea of natural nuclear reactions occurring within a planetary body isn't purely speculative. In fact, we have tangible evidence right here on Earth. Nearly 2 billion years ago, at a site called Oklo in what is now Gabon, Africa, a naturally occurring nuclear reactor operated without human intervention. Unique conditions of uranium concentration, water flow, and geology allowed a self-sustaining chain reaction to occur, naturally, for hundreds of thousands of years. If such a phenomenon could happen near Earth's surface, it's not outside the realm of possibility that something similar, but on a vastly larger scale, could have occurred deep within the planet. Some theorists speculate that over geological timescales, pockets of radioactive material could have concentrated near the core mantle boundary, creating zones where immense energy quietly built up. Shielded by kilometers of dense rock and subjected to intense pressures and temperatures, these reactors would have remained hidden, their influence subtle but persistent. Now, the thinking goes, something may have disrupted this delicate balance. Perhaps a shift in mantle convection patterns slowly increased temperatures in one region beyond a critical threshold. Or maybe the inexorable accumulation of fissile material reached a tipping point. Whatever the trigger, the energy release would not be explosive like a bomb, but rather a slow, seeping pulse of heat and deformation, radiating upward through the mantle, disturbing long-settled rock layers and sending strange ripples outward toward the crust. Such a slow-motion awakening could explain why traditional seismic networks have not recorded typical earthquake patterns in these regions. Instead of sharp jolts, the energy would move like invisible tides, warping and stretching the solid earth in ways subtle enough that only the most sensitive satellite instruments could detect them. Intriguingly, some gravitational mapping studies over the last decade have picked up anomalies deep within the mantle, regions where the density of material appears strangely out of step with surrounding rock. While mainstream explanations usually involve ancient subducted material or compositional layering, a few daring researchers have suggested that these could instead be indicators of something more dynamic, pockets of accumulating energy, building silently for eons. Adding a speculative twist to the theory is the idea that these natural reactors might not be uniform or stable. Instead, they could behave more like slow-beating hearts, pulsing with periods of activity and dormancy over millions of years. When active, they would gently swell the surrounding mantle, creating stress fields that ripple outward and upward. When dormant, they would slowly cool and contract, pulling material inward. Over time, these cycles could gradually rework vast portions of Earth's deep interior, without ever announcing themselves through dramatic surface events like volcanoes or earthquakes. Some go even further, proposing that the strange ripples could be the outward signs of an even more complex interaction between the Earth's core and mantle. If the core is not perfectly uniform, if pockets of lighter or heavier elements exist within it, they could create uneven heat flow into the overlying mantle. These thermal hotspots could act as amplifiers, focusing heat into specific regions and triggering localized mantle expansion. The surface might then experience slow, rhythmic bulges and dips, a planetary heartbeat, faint but persistent. This idea resonates with some of the observed characteristics of the ripples. They are not chaotic or random, they seem to follow patterns, rising and falling with a measured, almost deliberate pace. This is not the signature of explosive tectonic activity but something slower, deeper, and more enigmatic. Something ancient stirring within the Earth itself. Of course, with a theory this speculative, direct evidence remains elusive. The depths involved are staggering, far beyond the reach of even our deepest drilling efforts. Imaging techniques like seismic tomography can offer hints, like shadows on a cave wall, but they cannot yet paint a clear picture of what lies so far below. Still, the possibilities are tantalizing. If true, it would mean that Earth's interior is far more dynamic than we ever imagined, not just a passive heat engine slowly cooling over billions of years, but a complex, layered system with pockets of hidden activity. A living planet in the deepest sense, with processes unfolding on timescales so vast that human civilization is but a blink in their long, slow dance. It would also open up profound new questions. Could such deep energy sources influence surface phenomena more than we realize? Could they drive long-term climate cycles, or even subtly affect magnetic field generation? Could they one day, if destabilized enough, cause larger-scale surface deformations, changing the very shape of continents over millennia? In truth, we are only beginning to scratch the surface of these mysteries. Every new observation from orbit, every strange anomaly recorded by satellite, is a clue, a thread leading deeper into the unknown. Whether the ripples are the echoes of ancient slabs collapsing, or the slow breath of hidden reactors awakening in the darkness, one thing is certain: the earth beneath our feet is far from quiet. It lives, it moves, and in its deepest places, it still harbors secrets vast and powerful enough to defy even our most daring imaginations. If the strange ripples detected beneath the Earth's crust truly are the signatures of ancient forces awakening, the implications for humanity stretch far beyond the realm of academic curiosity. They demand that we reconsider not only our understanding of the planet we inhabit but also our place within its vast, unyielding story. For much of human history, Earth has been seen as a stable, almost passive backdrop, a silent stage upon which the drama of human civilization has played out. Mountains stood as eternal sentinels. Oceans carved slow, graceful shapes into coastlines. Earthquakes and volcanoes, though dramatic, were understood as rare intrusions into an otherwise predictable world. But these ripples, these subtle, unseen motions from deep within the mantle, hint at a planet far more alive, more restless, than we have ever truly acknowledged. If the Earth's deep interior is capable of slow, powerful movements that ripple outward unnoticed until now, it raises an unsettling thought. The forces shaping our world are not bound to human timelines. They do not respect the thin layer of cities, nations, and dreams that we have laid across the surface. Beneath our feet, in the unlit kilometers of stone and molten metal, vast energies are moving according to rhythms older than life itself, and utterly indifferent to us. It is a humbling realization. Humanity often thinks in years, decades, at most centuries. We measure progress in innovation cycles, presidential terms, economic forecasts. But the Earth thinks in ages and eons. The energy stirring beneath the crust today may not manifest dramatically tomorrow or next year. It might not reach its crescendo for centuries. Yet the slow, patient buildup could reshape coastlines, fracture continents, alter climates, and force future generations into migrations and adaptations on scales we can scarcely imagine. Such a possibility casts a long shadow across our ambitions. Plans for megacities, spaceports, grand infrastructure projects, all assume a degree of geological permanence that may simply not exist. What if the ground beneath these shining monuments is already in motion, shifting imperceptibly but relentlessly toward a new configuration? What if the very maps we cling to, the borders we defend so fiercely, are as transient as footprints in shifting sand? Yet within this unsettling revelation lies a profound opportunity, a call to awaken to a deeper relationship with the Earth. If the planet itself is alive in ways we have only begun to understand, then we are not its masters. We are participants in its ongoing, evolving story. Our survival, and perhaps our flourishing, may depend not on conquering the Earth, but on learning to live with its deeper rhythms, to listen to the slow songs of stone and fire that have always been playing beneath our notice. Technologically, it challenges us to innovate beyond mere surface engineering. How do we build cities, infrastructure, and ways of life that can adapt to a living, changing planet? Could we develop sensors sensitive enough to listen to the whisperings of the deep Earth, to detect the earliest signs of subtle movements and prepare accordingly? Could we learn, finally, to see ourselves not as rulers standing above the Earth, but as caretakers moving with it, attuned to its shifting breath? Philosophically, the implications are even more profound. The slow stirring of ancient forces reminds us of our own impermanence. Civilizations rise and fall. Technologies blaze into existence and fade into obsolescence. Even memories, wars fought, treaties signed, cathedrals built, become footnotes against the vast backdrop of geological time. In the face of a living Earth, human history shrinks to the scale of a mayfly's day. And yet, it is precisely within this impermanence that meaning can be found. If nothing is fixed forever, then every moment of creation, every act of kindness, every attempt to build or preserve becomes more precious, not less. To create beauty, to seek truth, to nurture one another in a world that is itself always changing, these become sacred acts, fleeting yet vital against the endless turning of the planet. The ripples deep beneath us are not just a geological curiosity. They are a whisper from the ancient heart of the world. They remind us that we are not the first chapter in Earth's story, nor will we be the last. But while we are here, while the ground still holds us, while the air still fills our lungs, we have the chance to live with awareness, with humility, and with awe at the forces that cradle and challenge us. In the end, the meaning we draw from this discovery may be less about fear of what might come, and more about awakening to the miracle of being here at all, standing on a living, moving world, looking up at the stars and daring to dream. As we stand on the precipice of understanding, the mysterious ripples beneath the Earth's crust serve as a profound reminder that we are not in control of the forces that shape our world. These movements, quiet, subtle, and largely unseen, whisper of a planet far older, far more dynamic, and far more complex than we could have ever imagined. Whether they are caused by tectonic shifts, ancient geological processes, or something more speculative and unknown, one thing is clear: the Earth is alive in ways we have only begun to understand. In this new reality, where the planet's very foundation appears to stir with unknown energy, we are confronted with questions that reach far beyond the scientific. What does this discovery mean for humanity's place in the world? How do we reconcile our ambition and progress with the understanding that we are just one brief chapter in a much larger story, one written in the bones of the Earth itself? The ripples are not just geological anomalies. They are a call for humility, for deeper introspection, and for a renewed sense of reverence for the Earth that sustains us. Though the future remains uncertain and much about these ripples is yet to be understood, we are reminded that our journey on this planet is a shared one, not just with each other, but with the Earth itself. Whether these movements signal a coming change or a long-standing, yet unnoticed, force beneath our feet, we must be prepared to listen, carefully and thoughtfully, to the messages the planet is sending us. We may not have all the answers now, but the very act of questioning is the first step toward understanding. Perhaps, in time, we will discover that these ripples, though mysterious, offer a unique opportunity, a chance to deepen our connection with the planet, to innovate with purpose, and to live in harmony with the Earth's ever-changing rhythms. It is not about fearing the unknown, but about embracing it as part of our journey. The Earth, in all its vastness and complexity, is inviting us to be its stewards, to walk more gently upon it, and to ensure that the story of humanity is one that is written in partnership with the living, breathing planet beneath our feet. As we continue to explore, to probe, and to learn, let us do so with open hearts, knowing that the mysteries of the Earth are not just challenges to be solved, but invitations to grow. The ripples beneath us are a reminder that we are all connected, both to each other and to the incredible, ever-evolving planet that has been our home for eons. And in this connection, we find both meaning and purpose, as we move forward, together, into the unknown. If you found this video intriguing and want to stay updated on more mind-bending discoveries, don't forget to like this video and subscribe to our channel. Hit the bell icon so you never miss an exciting update. Your support helps us continue exploring the mysteries of our world, and we'd love for you to join us on this journey. Thank you for watching, and we'll see you in the next video.